Indexing is an important part to database management, so that's what we're going to look at in this video. An index in a database is very similar to an index in a book. It allows you to immediately jump to the right part of the book instead of paging through and looking for the topic or word in question. So let's start off with an example of how efficient indexing can be. Let's start by looking for the nettuts document in our links collection. Normally, we would do this by running db.links.find, and we want to find the document where the title is equal to nettuts. And if I do that, we find it just fine. However, what we can do is call the explain method off of the find method, and this is going to explain how MongoDB went about running this query. Now, if we run this query, you'll see a couple of things here. First, notice that the cursor type used was a basic cursor. This just means that we didn't use an index when we ran this query. Since the title field here is unindexed, we just had to use a basic search instead of using a more advanced search with an index. Notice this n value here. This is the number of items that would be returned from this query. As you can see, we only have one document that would match the query we asked for. However, notice that we have n scanned objects equal to 12. Now, if I run db.links.count, you will see that there are 12 items in the database. So the point to take away from this is that since we didn't use an index in this query, we had to look at every single item in our database to find what we needed, even though we only needed one specific document. And that's not really a very efficient use of our document resources. Now, let's look for the very same document, but instead of searching by the title, we will search by the _ID field. And the _ID field is indexed. Now, I happen to have the ID for that object on my clipboard, so I'll just paste that in. And again, we're going to be running explain on this query. So now if we do that, we can see that the cursor here was not a regular cursor. Notice that we used a B-tree cursor. And B-tree, I believe, is an indexing algorithm. And you can see that we used the ID index here. Notice that we still just returned a single object, but notice how many objects we had to scan to find the document that we wanted. We only had to scan one document to find the one that was returned. So as you can see, this is clearly a much more efficient way of searching. Now you may have noticed up here, the number of milliseconds it took to do the query with no index is 0 milliseconds, and the number of milliseconds it took to do a query with an index is still 0 milliseconds. So it doesn't seem any faster. However, this is just because we only have 12 items in the collection. If we had hundreds or thousands of documents in these collections, you can see how only scanning the ones we need to, which is what we can do with an index, is much faster than having to scan every single document just to find a few that we want. But of course, it's not very fair to ask us to always be searching by the ID. Often we're going to be searching by a specific name. For example, if we're looking for users, we're going to be searching by their username or their email address. If we're looking for specific products, we might be searching by a product slug that was part of a URL. These are the things that we actually search for. We don't usually search by an index, especially in MongoDB when we have an object ID as the index. So how can we create our own indexes? So the way we do this is db.links, our collection name, and then we use the ensure index method. We pass it an object that has the name of the field as the property name, and then we'll just pass it 1 as the value. Now, 1 in this case means to index in ascending order. When you have a single key index like this, the order doesn't matter too much. However, it does matter when you have a compound index, and we'll talk about compound indexes in a minute. So now that we have that index, we can actually see that it truly has been created if we look at the documents in the system.indexes collection. This collection is used by MongoDB to store the indexes. And as you can see right down here at the bottom on bookmarks.link, we have a collection on the title field, and it's been given the name of title_1. These other two indexes that are already here are the _ID fields for the links and users collections respectively. These are created automatically for us when we create a collection and start sticking stuff into it. So now that we have an index on the title field of our links collection, let's go ahead and run that query again where we're finding by the title. And of course, we'll include the explain method here. And now you can see that we're using a B-tree cursor. So we're searching by an index, and the index is title_1. As you can see here, we return a single object, and that is all that we need to scan as well. We only scan that single object. So right away, our queries have become much more resourceful, and we've hardly had to do anything at all. Now, in this case, we've added an index on a field that will probably be unique However, this doesn't have to be the case. For example, we could add an index to the favorites field on our links documents, even though we know that multiple documents may very well have the same value in their favorites field. Of course, that may not be a good idea, because the number of favorites on a link would be changing regularly, and remember that when those change, the index does have to be updated as well. So keep that kind of thing in mind when you're creating your index. We'll talk more about what fields to index in a minute. Now, there are a few options that we can use when setting up an index. Let me just arrow back up to this ensure index call here. So the options would be set in a second object parameter here. And the first one I want to mention is unique. By default, unique is false, but I can set it to true here. And what this means is that it will ensure that the title field for every document is unique to that document alone. So no two documents could have the same title. This is, of course, how the _ID field works. So if we were to create that manually, it would look something like this, where we set the _ID field here, and then we choose to make that unique. Now, creating a unique index like this is probably something you want to do at the beginning when you're setting up your database. And that would, of course, be before you have any documents in that collection. And so you don't have to worry about this failing when it finds that there are multiple documents that may have the same ID, for example, in this case. However, if you already do have data in your database and you don't want to manually go through and make sure that your field of choice for your index is unique, what you may want to do is include the drop dupes parameter here. This would, of course, be set to true. Just like that, it's false by default. And what would happen here is that if there were multiple documents that had the same value in their, say, title field, if this was going to be an index for the title field, then if it found multiple documents with the same title field, it would only keep the first one, and it would get rid of any subsequent documents that had the same field. This, of course, would only be a good idea if you're using some kind of data where it doesn't matter if you lose some of your records. Now, there's another thing to think about here, and that is that since MongoDB is schemaless, you might have some documents in a collection that don't have the field you're indexing on. For example, some of our linked documents might not have been given a title when they were being created in our system. A normal index, like the ones we've been creating so far, would include these documents in the index, but they won't really add any value to the index for most queries because they don't have the field that's indexed. So what you may want to do in this case is to create a sparse index. We do that just by setting sparse equal to true, and this just means that, for example, here we're setting an index on the title field, so if we come across a document in the links collection that does not have a title field, that document will not be included in the index. It's pretty simple, and it keeps your indexes nice and lean. So that's it for different properties of the indexes, but let's talk for a second about compound indexes. This is an index that is basically using multiple fields. Now, the important thing to know about a compound index is that the order that the keys are indexed in matters. And this is because for each subsequent field in the compound index, it's like a sub-index of the previous key. I like the example that Kyle Banker uses in his book MongoDB in Action, which you can get from Manning Press. He says that a compound index in, for example, a cookbook would be like having an index of ingredients with a sub-index of the recipes that use that ingredient under each one. So that would be useful, you can imagine, if, say, you had some extra carrots. So then you can look up carrots in the index of your cookbook and have a sub-index under that of only the recipes that include carrots. This would be something that would be useful in a cookbook. But to have an index of the recipes with a sub-index of the ingredients in that recipe wouldn't be very useful at all, because once you've found the recipe, there's no need to have an index of the ingredients that are in that recipe. So in a real database, you need to think about these kind of things. What fields does it make more sense to query by first when you don't know what you're looking for? So this is an example of where a useful compound index would be indexed first on the ingredients and then on the recipe names, and a useless index would be indexed first on the recipe names and then on the ingredients. So when working on a real project, you need to think about this kind of thing. What order should you be putting these keys in? Now, in our links database here, we don't really have a good example of a place where we really should use a compound index, but I'll just show you how the syntax would work here. If we wanted to have an index on first the title fields and then, say, the URL fields, we would have title 1 and then we would have URL 1 after that. So this is indexed first on the title field and then next on the URL field. Now, the nice thing about a compound index like this is it would take away the need to have an index solely on the title. Now, the way the MongoDB documentation puts this is that if you have an index on A, B, and C, like that, this index could be used when searching just by field A and by field B, or by field A, by field B, and field C altogether. So this index right here on the title first and then the URL fields would be useful for searching both by title and URL, or just by the title. But it would not be a good index to search just by the URL with. Another thing that I should note is that MongoDB can only use one single index per query. This is unlike some other database systems that can use multiple indexes to help them search for the items for a single query. Of course, a compound index like what we've just talked about here is counted as a single index. Now, if you have an index in your database that you're no longer using, it would be a smart idea to get rid of that index. We can do this by saying db.links or collection name, and then we can say drop index. And to this method, we just have to pass whatever the index name is. Now, if you're not sure what the index name is, you can look it up in the system.indexes collection. Let's say I want to delete this index that I just created here, this compound index. I can see right here that it's been given the name of title_1_URL_1. So I can say db.links, because that's the collection this index is part of, drop index, and then I just pass it the string title_1_URL_1, and we get an OK returned to us. So now, if we look in this system indexes collection again, you can see that we only have those 3 indexes instead of the 4 that we had up here. So that is indexing for you. Now, you may be wondering, what fields should you be creating indexes on? Well, don't just go create an index for every single field, because indexes use resources too. They need to be updated whenever the fields that are indexed are updated and that kind of thing. So don't just go index everything. What you want to do is index whatever fields you query most often by. So for example, if you do have a user database where you're retrieving user records based on their email address, you're going to want to index that email address because that's what you're using all the time. If you have an online store and part of the URL for a product is a product slug that is unique to that product, you'd probably be searching by that slug on your backend, and so you want to be indexing the slug field on your product documents. Whatever fields you use the most often are the ones you want to index, and you really should index them because it will make a difference in your query times. Well, that's all I'm going to say about indexing in this video. So if you're interested in a few of the more advanced and technical parts of indexing, I recommend you check out the link below this video for more information.